Hello, good afternoon everybody. I hope everyone's still awake. So here to discuss security challenges of blockchain-enabled environments. So what we're going to discuss are the potential risks, especially with our focus towards enterprise blockchains. So we'll start with a little bit. Not many people have actually heard of XForce Red, so I'll just give a quick, brief introduction. So XForce Red is an autonomous division within IBM itself, where essentially we perform all manner of testing, where we hack anything from like IoT to hardware to apps and all your standard stuff. We're a team of veteran security testers. Essentially, most of our backgrounds comprise of architects, developers who progress into the pen testing field. So I'll go a little bit about myself, just give you a bit of background. So I'm a senior managing consultant within XForce Red. I started going into PCs and started writing code when I was 10. Not long after that, I actually started giving systems a little tickle and start hacking. And from there, my curiosity just expanded. And ever since, I've been absolutely interested in security and coding. Now, onto the blockchain stuff. So I've initially got into cryptocurrencies in 2012, just like probably most people, if you have dabbled in them, with a view to, hey, let's make some money. I'm going to get rich. Well, as it turns out, I was absolutely terrible and lost a few Bitcoins. However, many years later, I decided to revisit the subject, but from a technology perspective. And being a pen test at the same time, it piqued my curiosity about, let's investigate the security side of things. Let's investigate how it works and what are the potential risks. So, how many people here actually know what blockchain technology is? Oh, yeah, a couple of hands. So, blockchain technology is an immutable ledger. So essentially, what that means is it is distributed amongst all participants of a network, and it is a very, very good way of sharing information between people who do not trust each other. And the reason why it's such a good way of sharing information is because it's transparent, meaning that everybody has a copy. It's immutable because it's secured through cryptography, so cryptographic hash functions. So if it was to change, obviously, the cryptographic hash would change. And also, if I was to modify my local copy to say this is the new truth, everyone can just say, no, you're telling porky pies, you're lying, because everyone else has a copy of the same information. So this allows a level of trust in the data to be shared between everybody. And so with this data and this trust, you can start building and architecting systems on top of it. So I'll give you a brief history of blockchain technology, where if I was to mention blockchain, everyone would probably think of Bitcoin. However, blockchain technology was actually the concept was first introduced in 1982. But it took about 26 years for it to actually come to its first proper implementation in the form of Bitcoin. So if it took 26 years, okay, to go from theory, built upon theory, to actual full work and implementation, what's it going to be like? So at the present, I think it was 2015, yes, 2015, where enterprises started to take more notice in this, and we started to have permissioned ledgers released. And this was 2015. So if we took 26 years to get to like public blockchain technology, okay, enterprise blockchain technology has been around since 2015. So in which case, the use cases aren't quite fully understood. And we're still trying to find ways in which this technology is applicable. So if we're still trying to find ways in order to utilize this technology, how are we supposed to understand the associated risks with that technology as well? Now, from an information perspective, from blockchain security, you can try and Google this sort of information, and most of the stuff you'll find out there is fluff. The only sort of information you can actually find is in academia. Trust me, I've looked. And again, a lot of those academic papers, I've read quite a significant number of them, and I'd say a significant number are actually fluff again, so there's no real substance. Now, if the topic of blockchain security is only just starting to get discussed in academia, how long do you think it's going to be till it actually filters through to the enterprise? So this is why I want to talk to you about blockchain security today. It's just to highlight some of these potential risks that you may face if you come across a blockchain environment. I guess most of the people in this room are going to be associated with security and pen testing. So if you ever come across a blockchain-enabled environment, hopefully this talk will give you some insights into how to proceed. So before we actually get into the nitty-gritty of it, I thought I'd come up with an actual definition of blockchain technology, where essentially the security in the blockchain can be defined as the protection of transaction information and data in a block against internal, peripheral, malevolent, and unintentional threats. Now this should be the goal for any environment. Okay, this should be like priority number one. So, as I previously mentioned, we've got public blockchains, and I've touched on enterprise blockchains. So we'll just quickly go through the primary differences between them and how applicable they are. So here's an example of some public and private blockchains. While the underlying concept of the technology is the same, they're actually two very different beasts. So a good example, from a public blockchain perspective, it is open, meaning that anyone and everyone can actually join this network and participate. Both blockchains, both public and private, have smart contracts. However, on the difference being the private side, the private enterprise blockchains tend to have access controls, ACLs and things, and permissions associated with it, which you don't see on the public side. Now, there are pros and cons for both. So a good example, on the public side, it's a trustless architecture and it's completely distributed, but it's open. On the private side, there is actually requires a level of trust and is not as distributed. There are some forms of centralization. However, you trade the openness and the decentralization for security, for permissions and access controls. So, who thinks blockchain technology is secure? Yeah. We've got one hand. So, yes and no, in fact. So blockchain, from a theoretical standpoint, is secure, where data, as I previously mentioned, data is actually secured in a cryptographical manner, which essentially means it's highly tamper-proof. And it's distributed, meaning everyone or all participants on that network can see the data, meaning, as I've mentioned, if you modify my local copy, everyone else will have a different version. However, where do the actual insecurities come from then? So the insecurities come from the underlying concept that blockchain technology in and of itself does not solve every solution or every problem, especially within the enterprise. So a good example, you take Hyperledger. This technology is not a one-shoe or one-size-fits-all solution. Instead, what they've tried to give you is, they've tried to give you a framework. Think of it like a jigsaw puzzle, okay? Where you have loads of these different components, and essentially you've got a problem, and you glue and configure these different components together in different and innovative ways. Now, it's how these components are glued and configured. This is where the insecurities tend to come in. And the biggest source of these insecurities is what I like to call the meat factor, people. Okay? So at the end of the day, we're all human, we're not infallible. To human is to error is to cause vulnerabilities. Okay? And this is where most of the risks actually come in. So what sort of areas do we find these risks in? So I've been performing blockchain security assessments for quite a while. And so what I've tried to do is I've tried to identify areas within the technology itself and common denominators. And these are the various areas in which I feel are focal points. And I'm going to run through the majority of these today with you. So let's get cracking in. Let's get the first one, architecture. So architectures are fundamentally important, well, just like everything, because ultimately code has got to run somewhere, and it's how you actually build that environment that will affect the security of it. So with regards to blockchain, I mentioned it's decentralized, okay? But blockchain technology, especially from an enterprise perspective, we're seeing it comes in potentially two forms, or combination of the two forms, on-premise and off-premise. So by that, let's start with off-premise. By off-premise, I mean that it is hosted not in your company or in your local data center. It's actually hosted in like a cloud-based solution where you have multiple organizations or companies and it's all hosted in the cloud, so it's not actually sat on any of their networks. Okay? The problem with that is you're going down similar to like the managed service provider route, okay? So the security of it is only going to be as good as the managed service provider itself. So if they've got poor security or poor policies, then obviously that's going to be reflected in the security posture of the environment. On the flip side, you've got on-premise. So on-premise is essentially you're hosting the actual network or a part of the network on your internal network within an organization. Now, from a blockchain perspective, normally what we tend to see is that a blockchain environment is normally shared between multiple organizations. So the environments we're seeing is shared between multiple organizations, meaning that a number of different companies, organizations have different stakes or they have different stakes within the network. So they have a portion of it themselves. So if they host it in a portion of that network in their own environment, well, the problem we've got there is every single company does, they'll have like their own standard InfoSec policies and their own hardening, but not one policy or not one risk profile is going to be the same. There are many different risk profiles or risk appetites per organization. So what happens if you have this super secure blockchain environment with numerous organizations? However, what happens if you've got an organization over here that's like quite lax in their security posture? And what happens if they get popped and an attacker gets onto the network and then pivots through to the rest of the organizations? So again, each come with their risks. So you can actually have a combination or hybrid of both of on-premise and off-premise and things like that. Now, from an enterprise perspective, which I've tried to outline, is you do have some, and this is actually typical of some cryptocurrencies as well, you do have some centralization. So you trade the openness and the distributed nature for some centralization. So a good example for enterprise networks, they predominantly tend to use Hyperledger as the blockchain technology. Well, with Hyperledger, you have two key areas where you have an orderer and a peer. A peer is essentially like a node on the network, where the orderer is the block producer. Now, with an open network, anyone and everyone has the ability to produce these blocks, has the ability to commit data to the chain. But when it's centralized, these orderers are the block producers. So instead of having everyone commit data or produce these blocks, it's just a finite number. So if you start reducing the decentralized nature of this, you start introducing potential risks and attack vectors as well. So what happens if I can take out some of the orderers or compromise an orderers on the blockchain environment and start producing my own blocks? Well, it's going to start affecting the integrity of the chain. Further to that, development process. Now, from a public perspective, cryptocurrency's perspective, it's open source. The code's open source, so majority of the time, it's not just one or two or a small pool of developers actually creating the public blockchains. It's a whole community making commits and pull requests and things like that. But from an enterprise perspective, now while the enterprise development teams are going to be quite large, where you would hope anyway, in some instances, that pool is actually significantly smaller compared to the public blockchain. So again, it's all about finding a happy medium between the two, between being centralized and decentralized. So let's discuss a little bit about communication channels, especially with regards to blockchain connectivity. So blockchain tends to communicate with each other using the gRPC protocol. That's a relatively new protocol that's coming out that I think it's been developed by Google Protobuf, or utilizes Google Protobuf. However, there's a number of risks associated. A good example being is with these blockchains, they have to have endpoints. At the end of the day, everything has to, if it's on a network, it's going to have layer 3, so it's going to have an IP. It needs to talk. So again, your standard network security principles tend to apply. However, with enterprise blockchains, it tends to be more centralized. So in which case now you start to look at attack vectors, but also everything else is built on top. It's like ingress and egress points. Where do you target? What is exposed? We've had some instances where the actual interfaces have been exposed to the public internet, which was a big no-no. Further to that, who has access to these communication channels? So there are some we've had instances, there's some instances where where we have like an administrative interface or the administrative protocol. Some developers and architects have actually exposed that administrative protocol or interface to public IPs and things like that. So again, it's extremely important. Now, I've tried to outline some, I think I've briefly touched some of the interfaces or some of the attack vectors in which we can target as penetration testers and what you need to worry about. So with regards to Hyperledger, I've mentioned gRPC. This is the main protocol that tends to communicate between other Hyperledger components. However, from an enterprise perspective, what Hyperledger tries to do is it tries to abstract the actual blockchain away from the developers, where in the form of Hyperledger Fabric, it will actually take all your smart contracts and actually present you with a nice little API that allows you to just make calls, function calls to this API, and it'll actually do things on the blockchain itself. However, there are a number of things that you need to be aware of with like these egress points, especially with the API. The API that gets presented will actually have every single function call present, but there are no access controls. It's completely open. So it's like if you actually get hit that, then it's game over. You can literally do anything and everything. One of the biggest areas in which, especially if you come across an environment you need to focus on, is off-chain data access. So what I like to call potential application bridges, where not all data can be stored on the chain. It would be too costly, which we'll briefly cover that topic in a few future slides. But off-chain data access is extremely important, especially from a risk vector. The reason being is data on the chain cannot be changed, right? It's immutable. So it can be accessed in a deterministic way. So by that, I mean that you can access the same data again and again, and it will never change. However, off-chain data, take example like a database. Well, data in a database is constantly in a state of flux. It constantly changes. So in which case, how do you actually ensure that's accessed in a deterministic manner? Are there things you can do there that actually affect the business logic of smart contracts? And especially egress and ingress points of external systems, or what we like to call application bridges. So obviously you've got this blockchain technology that's going to share this information. However, you still need to have users and other technology interface with this tech. So that's where you're going to build all your applications and your mobile apps and things like that on top of it. So these actual application bridges are extremely important in trying to get right from a security perspective. So we'll talk a little about risk inheritance. So essentially, what I mean by this is, especially within a blockchain-enabled environment, so I'd say if you're taking an entire blockchain-enabled environment, about 20 to 30% of that environment is literally going to be the blockchain technology itself. All the other technology is going to be your standard off-chain, like your databases, your web apps, your mobiles, apps, and things like that. However, I liken it to building a house on sand, where if your foundations are built in sand, everything else built on top of that is going to inherit the insecurities of your foundation. So if you don't get the blockchain technology right, if you don't get the configuration and the security of it right, everything else built on top of it is going to inherit those risks, and it's just going to make your life more complicated. And a big one of it as well, especially from a permission perspective, is mapping of the roles and the organizational structure. So what I mentioned previously is you may have a number of different organizations that are part of a big blockchain-enabled environment. Well, these organizations have different structures or roles within their own organizations. However, how do you map that in a unified way to the blockchain? It can be actually quite problematic, and how it's mapped, there can be actually insecurities there from things like just access controls being overly permissive and stuff like that. So I've outlined some potential solutions. A lot of these, it's just, a lot of them are common sense, where essentially apply the principle of defense in depth, harden the environment right from the bottom up, penetration testing, I can't stress that enough. Especially with blockchain-enabled environments, it comes across as what I like to call Armadillo Syndrome. So people automatically think that blockchain technology is secure. So what they actually do is when they need to get the environment pen tested, they focus on everything else above the blockchain technology. However, there are vulnerabilities, there are weaknesses in blockchain technology. So I can liken it to Armadillo Syndrome, where it's hard on the outside and soft and squishy on the inside, where I've had instances where we've been able to compromise the application, pivot through to the internal blockchain, and as I mentioned, like with the Hyperledger Fabric APIs, there's no access controls, in which case I pivoted through and I can literally perform any function on the chain itself. And the DevOps flow, that is especially important. I will briefly touch upon that with regards to the code, the smart contracts, because that is a critical one, but I won't go into much depth here because I'll go into it later. So I want to talk a little bit about cryptography, PKI. Hopefully a lot of people here are familiar with the subject. But why is it important with regards to blockchain technology? Well, cryptography is actually used throughout blockchain technology in the forms of signatures, hashes, and actually identity, where it allows non-repudiation, it enhances the privacy of data stored on the chain, and it allows the secure identity of users and systems. This is especially true in enterprise networks. Hyperledger utilizes PKI or certificates a lot, both for nodes joining the network and its users. So what sort of challenges are we going to face then with PKI? Well, a lot of these are going to be your standard PKI type challenges where you've got issuance and provisioning, your certificate authorities. So again, we're talking about like what happens if you have multiple organizations? How do you structure your certificate authority? Do you create intermediary CAs? How do you map all of this? And again, a key one, which again, this is mostly just standard stuff where you're talking like your HSMs, how you handle of your key material, how your key material is shared, and that sort of stuff. So some potential solutions for the PKI. Essentially, enforce encryption requirements. Common sense stuff, especially if you're in the security field. Utilize HSMs. One of the ones, especially which is blockchain specific, is utilizing zero knowledge proofs. Does anyone know what zero knowledge proofs are? Yeah, we have a couple. If you were to store sensitive information on the blockchain, how would you go about protecting that information because it's shared between everyone? So you can potentially encrypt the data with a key or something along those lines. However, then, you've got to try and share that key between multiple organizations and parties. What you could actually do is you could utilize zero knowledge proofs, where in essence, in its most simplistic form, it's taking a piece of data, it's running a deterministic hashing function against it and storing the cryptographic hash within the chain. So if the chain was ever to get compromised or disclosed, the user or the attacker would actually never have the sensitive information. However, if you were sharing that sensitive information between parties, then the easiest way for them to determine whether that information being shared is correct is they would use the same deterministic hashing algorithm and then just check the actual hash on the chain. That, in essence, is just zero knowledge proofs. And then we just have strict enforcement of policies. So PKI is how you go about them, standard risks is pretty much standardized stuff across the industry. But I'd like to talk a little bit about identity, especially with regards to the enterprise side of things. So why is it important? Identifies users who are able to participate on the network, especially, so from an enterprise perspective, you've not just got one blockchain network and the one ledger that's shared between everyone. An enterprise blockchain has the ability to have side channels, have multiple chains, and you can actually control who has access to what chain. And this is all controlled through identity and the use of PKI. Hopefully a lot of you will actually know, it's pretty much standard stuff where identity allows you to establish roles, entitlements. Again, we discussed non-repudiation. But from a blockchain perspective, at what level do you actually introduce authentication? So you could introduce it at the blockchain level, where if you take Hyperledger, Hyperledger utilizes MSP. the membership service provider. So you can't actually implement access controls at the blockchain level via the managed or member service provider. However, the downside of that is it's not granular. There's a good chance it's not going to be granular enough, and it might be a bit too cumbersome for blockchain-enabled environments to actually implement access controls at that level. However, if you take it on the opposite end of the spectrum, so we've seen it implemented there, we've also seen it implemented on the application side where, again, there's no access controls in the blockchain environment. As I mentioned, the API is just open to everybody. So instead, all the access controls and the entitlements are enforced at the application layer, which is a standard approach for most applications because they're normally dealing with a database in the back end. The problem is, what happens if the application gets popped in? What happens if it gets compromised? Again, we're talking Armadillo Syndrome. You can pivot through and start to access, attacking the blockchain and the APIs itself. What happens if you try to have a hybrid? So essentially at the blockchain layer, you have groups. You implement groups, and then at the application layer, you implement more granular controls and associate those accounts with groups. So in which case you have some limited control. But again, it all depends on your risk profile. It's not one solution fits all, and this is where the insecurities come in. So this is where you need to investigate. So what are some of the challenges? I think I've outlined a couple of them. Is how do they actually map to the chain? So again, we've discussed implementing it at the blockchain level or at the application level. What about session management? If you implement it at the blockchain level, how do you handle session management? So that's going to prove a challenge. There's a potential issue right there. But especially when dealing with multiple organizations, how do you handle the life cycle of user accounts, the onboarding, the offboarding, the entitlements, and the change control? Because you've got multiple accounts. Someone's got to do it. Who does it? And we'll touch on that in future slides. And again, verification of responsibilities, as I've just mentioned. Who does what? Especially from a sysadmin or management or configuration perspective. So some of the things you could actually do to help with potential solutions. So have a well-defined lifecycle management policy, especially with regards to accounts. We briefly touched upon the membership service provider. So that is Hyperledger's way of implementing access controls. But if you wanted some anonymity within the blockchain as well, the membership service provider also has an identity mixer, which allows you to actually authenticate, but in an anonymous fashion. You can actually utilize external authentication providers like OAuth and things like that as well. But again, it all boils down, you need to have really, really strong access controls. I'm going to briefly touch upon application security. Hopefully, this is straightforward. As I mentioned before, blockchain-enabled environments, the blockchain technology sits right at the bottom, and it accounts for like 20–30% of the overall environment. The rest of it that's sat on top is your standard infrastructure. You're talking your databases and your apps and things like that. So why is it important with regards to blockchain? Well, we've again touched on it, where if the application gets compromised, you can interact with the underlying blockchain. Sometimes the application, the business logic is not implemented on the smart contracts on the blockchain itself. It's actually embedded within the application. So in that case, standard attack vectors used today apply. So some of the challenges with regards to blockchain technology. So enforcing data integrity when committing information to the chain. So once data is committed to the blockchain, it cannot be changed. It's immutable, okay? So what happens if you have an error or someone compromises your application and is able to affect the data before it's committed to the chain? How do you rewind that back? You can't. How do you enforce integrity of that data? Again, secure programming practices, sufficient controls, especially across trust boundaries. Any trust boundary is an attack vector. And as I've mentioned about a blockchain framework, it's multiple components. Well, if we talk about the overall environment, it's going to be even more components. And generally, it's not going to be a simplistic thing. These environments, especially when you're talking spanning multiple organizations, they're going to be big, complex beasts. And with complexity comes the possibility of insecurities. So what sort of things can we do? Well, a lot of these are standard practices because we're talking about application security. So full scope penetration testing. As I mentioned with Armadillo Syndrome, people just tend to focus on the user-facing aspects, just the externally facing systems. What about everything else underneath? You need proper end-to-end pen testing. That includes the blockchain itself. You think about like web application firewalls. Now, you should always treat the infrastructure as unknown. Always assume compromise. In which case, if you assume compromise, how does that affect how you architect and build and manage your environment? And patch the world, you can't patch enough. Nobody keeps up to date with their patches. Well, if you do, you're a hero, because I've actually very rarely seen it. And again, I can't stress it enough. Full scope, end-to-end penetration testing. So I want to briefly discuss privacy and access of data, because as we touched upon, once data is committed to the blockchain, it cannot be changed, and it is shared between multiple people. So, why is the privacy of data important? Well, for a start, you've got compliance and regulatory requirements. So, GDPR, HIPAA. But on top of that, if you start storing sensitive information and then you get compromised, or an organization gets compromised and the data goes walkies and disclosed, well, that's obviously going to negatively impact the reputation of not just the environment, but the organization itself. And obviously, you just want to secure the storage. But as I said, data, when it's committed to the chain, it cannot be changed. You cannot rewind it back. So you need to get it right the first time. How many people, well, especially if we got pen testers or people who architect things, how often do you get things right the first time when you develop a new environment or create a new application? Quite frankly, you don't. That's where it's called a proof of concept, and you got like version control and things like that. But when it comes to blockchain, if you haven't got it right the first time, do you throw it out? Do you try and rewind? Do you try and fork? So you need to try and get it right, or as right as you can the first time. So what are some of the challenges with regards to data access and blockchain technology? So the very first one, as I mentioned, data is shared between multiple organizations and parties. So you've got potential privacy leakage. So if you're trying to store sensitive data on the chain, we've discussed things like zero-knowledge proofs and other things like that. You need to be able to secure data that's going on the chain. And how you do that is you ensure it's encrypted in some fashion. Now, mapping of user permissions to the blockchain. So we've discussed that. And where do you implement your authentication? Do you do it at the blockchain layer, or do you do it at the application layer? How do you map that, especially those roles and entitlements, especially within multiple organizations? Now, there are a large number of insecurities that we've identified over multiple tests through this vector, where things have just been overly permissive, or they've just implemented identity authentication in the wrong place. Ensure any data is committed is valid, not malicious. So as I mentioned before, what happens if the application gets compromised and you're able to manipulate the data before it's stored in the chain? It's to be trusted, right? Data on the chain is to be trusted. That's what blockchain is actually being heralded as. Well, yes and no. A big one which all constantly gets missed is partner and third-party vetting. So by that, it means dependency in the supply chain with code and other organizations who help manage the network. So a good example, smart contracts, it's just application code that's stored in the blockchain, but you can actually utilize third-party libraries. Well, this is especially true for normal application development with the web apps and things like that. What happens if you utilize a third-party library that's massively out of date or has vulnerabilities? Difference being is it's stored on the chain. So you need to find ways to update, or you need to make sure it's all vetted. So what are some potential solutions, especially with privacy of data on the chain? We've discussed zero-knowledge proofs. A new concept that's come out, especially with the enterprise network side of things, is zero-knowledge asset transfer. So essentially, that allows you to transfer assets or information between parties in an anonymous fashion. identity mixing, again, this is more of an anonymity where the blockchain has membership service provider, but if you wanted to have it kind of like an anonymous aspect to it, so it could be for some sensitive reason, then it actually allows you to obfuscate or abstract that identity. And then again, the other two are your standard stuff. Ensure all data is always encrypted at rest, and you have strict access controls and auditing. So this is a big one which I wanted to talk about, is off-chain data access. So why is off-chain data access important? Well, for a start, it is too costly to put everything on the blockchain. So say you have 10 organizations all joined to a blockchain network. What happens if they decided, well, I know, let's put our login information, or let's put files on the blockchain? Well, what happens when you version increment those files? What happens if you have like 100 users in each of those 10 organizations and they all commit maybe 10, 15 meg worth of files every day? Well, in which case your blockchain is just going to go, it's just going to get bloated like my nan when she doesn't take her meds, okay? It's going to cause problems, and especially because it's distributed between everyone. Now, while storage is cheap, it doesn't scale, okay? So, in which case, you're going to need to move stuff off the chain. On top of that, if you store lots and lots and lots and lots of information on the chain, you've still got to deal with like the privacy and regulatory requirements. Further to that, on-chain data is immutable, as we've discussed, and off-chain data is not. Means it can change. Now, that is specifically important, especially with regards to, deterministic. There we go. The challenge of keeping the off-chain data deterministic. So what happens if you have a smart contract, okay, that doesn't reference data, doesn't utilize data on the chain, but instead makes calls to an external source? Well, with regards to Hyperledger, smart contracts are executed on all peers within the network, and then the results are returned to the orderers and a consensus is formed. So what that means is that smart contract could be executed 10, 20, 30, 40 times, okay? Now, they all reach out to an external source to get some data. Well, what happens, right, if that data was to change, kind of like a race condition? What happens even if it changes just a fraction, right, between all those number of different requests? Well, the results returned are going to be different, okay? In which case, it's going to be hard to form a consensus. So it could very well be that you could actually alter or impact the business logic of the smart contract, or the data may not actually get stored on the chain because the consensus fails. So you need to find ways of the challenge is trying to keep it deterministic. So make sure whenever you access data, it's always the same. Ensure it's decentralized as well. So a number of times when you have off-chain data access, it's always just to like a single database in one area. Well, what happens if that database becomes unavailable? Well, that's going to cause significant problems to your smart contracts and your business logic within the environment itself. Further to that, handling of key material, especially if you encrypt stuff on the chain, then you don't use things like zero-knowledge proofs. Further, we've discussed identity. What happens, right? How do you map data or access to off-chain data from on-chain accounts itself? How do you figure that out? So we discussed how you implement authentication or identity at various levels within the blockchain itself, but how do you actually implement access controls from the smart contracts to the actual database? Do you just give it a standard account that can read everything? So some potential solutions for off-chain data access. The concept of oracles, this is especially coming prevalent in the public cryptocurrency space. An oracle is essentially a proxy. It's just like a proxy where smart contracts or anything on-chain, if it's to access external data, it would go through the proxy makes the request, and it caches the request. So data is deterministic. From a decentralized perspective, you can have data lakes and essentially have gateways to control access controls and things like that. Sharding of information, where essentially small clusters can actually have its own little pieces of information. And then state channels. State channels, again, is a new concept. Well, I'd say new. It's been implemented in Bitcoin via the Lightning Network, where essentially it allows you to perform a number of operations off the chain, and then once you've finished, you can then commit the final results to the chain. So you have a number of different ways of doing this. So I'm briefly going to talk on smart contracts and chain code. So why is smart contracts and chain code important? So smart contracts can actually control how data is written to the chain. It actually maps organizational business logic through to the blockchain. What does that actually allow? Well, say you have multiple organizations that have different ways of doing things, okay? They don't agree on anything. Well, if you were to create a smart contract, that creates a unified process that all organizations can use, okay? So again, allows a way to actually unify business processes in a trusted manner. So what are some of the challenges that we face with smart contracts? As I mentioned again before, human error to human is to error is the cost of vulnerabilities. A lot of these come, with regards to smart contracts, it's application code. Now, if you take Hyperledger, for example, you can write a smart contract in Go, JavaScript, and Java itself. So you have all the standard code insecurities that can come in. So it's still vulnerable to injection attacks, error handling, business logic errors, code supply chain errors, and those sorts of things. Further to that, with smart contracts, as I mentioned before, if I execute a smart contract on a permissioned network, every single peer in that network will execute that contract and return the results. Well, what happens if I gain access to the blockchain-enabled environment, and I've done this and it's quite cool. You can write a malicious smart contract, publish it to the network, execute it, and have it return a shell on every single peer within the network. Now, if you have an on-premise solution where all these organizations have a node on their internal network, well, in which case, I've just got a shell on your network, I've got a foothold on your network. It's time to go to town. Okay, so again, it's critically important. And again, it's code. We all make errors. And especially when you try and implement a complex process in code, that's where you're going to have problems. It's just standard stuff. And again, what you can do to solve it, help mitigate it, a lot of this is standard, where you secure coding practices, you have secure code reviews, change control processes, pen testing. I can't stress that enough. Last but not least, I want to touch on governance. So this is quite a big one. So governance, why is it important? A lot of the time, you have multiple organizations that form part of the blockchain network. So in which case, as I've mentioned again, each organization is going to have their own risk profile. They're going to have their own compliance requirements, their own policies and processes. Well, how do you unify all that? Okay? You're going to have conflicts. And if you have conflicts, especially between organizations, you're going to get dragged into legal battles. So there's going to be inconsistencies. And if there's inconsistencies, there's going to be scope creep and the goalposts are going to move. So here are some of the challenges that you're going to face, especially with a blockchain-enabled environment. It's definitely going to be time-consuming. So you've got organizations, they're glacial. Enterprises move at a slow pace. And especially when they don't agree on anything, you've got legal stuff. They're going to fight it out and someone's going to win. But this all needs to be done before the chain is actually, or the environment is architected and built. If it's not, the goalposts are going to move. Okay, and if the goalposts are moving during development, this is where, again, your devs aren't going to have a clear picture and insecurities and vulnerabilities are going to creep in. So this is something that's extremely important. Further to that, who runs the blockchain? So you've got all these organizations. Who performs what action on the chain? Who manages it? Okay, does one organization take full responsibility or do they share it out? Who comes to this agreement? So again, it's all about forming an agreement. So what I'd like to talk about now, briefly, is what's next. So what are we actually lacking in this space? So from a blockchain security perspective, I've mentioned there's little out there with regards to security. So what can we actually need? Well, for a fundamental start, we could definitely do with design patterns or architectural diagrams. So identify the common use cases, come up with standard network architecture design patterns. It definitely needs more security research, and hopefully, especially with the pen testers in here, inspired some of you to go out and investigate this stuff. It definitely needs more people looking into this topic. The use cases that I've mentioned before, we're still struggling to find proper use cases for it. It needs to mature. And once it's mature, we can start identifying risks a lot better. Further to that, we need to investigate bleeding edge ideas. A lot of these ideas are coming through in the cryptocurrency space, in the academic space, but enterprises aren't actually, they're ignoring this. They're not actually paying attention to this, where some of these ideas are actually really cool and actually really applicable.